Hello everyone. In this session, we are going to discuss with eliminating arbitrary function with uv. The problem is form the partial differential equation by eliminating the arbitrary function from the relation of pi of xy comma x square plus y square equal to 0. In this problem, to solve two methods. First, method 1. Method 1. When the function of uv equal to 0, then the Jacobian is nothing but dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y equal to 0. Now, I'm just taking the value, let u equal to xy and then v equal to x square plus y square. When the problem is given, the two relation u xy, v x square plus y square. For this function, u function, differentiate with respect to x and differentiate with respect to y. And this is a dou v by dou x and dou v by dou y. When I'm differentiating the u function with respect to x, y consider constant. In the product y, when the constant we consider no changes, only the variable x differentiation is 1, the y is constant. Then dou u by dou y, now x is a constant, now y variable differentiation with respect to y 1. From here v equal to x square plus y square. When I am differentiating v with respect to x square is 2x and then plus the constant 0. Then x square constant when I am differentiating with respect to y 0 plus 2y. Now substitute this value to the Jacobian form, dou u by dou x y, dou u by dou y x and then 2x 2y, the determinant equal to 0. Therefore 2y square minus 2x square equal to 0. When 2 will be cancelled, when I am taking 2 common, y square minus x square equal to 0. This 2 I will take for right hand side. Therefore y square minus x square 0. Now the function is eliminated. This is the first method. This method apply with the determinant of this form. And method 2. To solve this problem, method 2. Method 2. When the function of uv 0 given, then rewritten the form v equal to the function of u or u equal to the function of v. U equal to the function of v. Therefore, the given problem function of xy, x square, y square equal to 0. In this form, I am going to rewritten the form v equal to pi of u. V is nothing but x square plus y square equal to the function of x, y. Now to solve this problem, as usual, eliminating arbitrary function. Therefore, I consider this equation number 1, differentiate 1 partially with respect to x. When I am differentiating this, 2x equal to pi dash of xy and then variable differentiation is x1 with respect to x. Then the constant is y. I consider this this 2x divided by y, because this y I am taking into left hand side, pi dash of xy, and then this is a equation number 2. Then differentiate 1 partially with respect to y. When I am differentiate partially with respect to y, this is the 2y equal to pi of xy. When I'm differentiate with respect to y, pi dash of xy, then x here constant, y differentiation is 1, and then 0 for the reason constant x square 0. And now 2y by x, this term I'm going to take in left hand side, pi dash of xy. This equation I'm going to consider third equation. Compared with 2 and 3, the right hand sides are equal, therefore left hand sides are equal. So 2x by y equal to 2y by x. To cancel this 2 both sides, so therefore x square equal to y square, x square minus y square equal to 0. Equal to 0. And next we are going to discuss with another problem. This problem I have considered only two variable, correct? X, y. And next problem, form the partial differential equation by eliminating the arbitrary function from the relation pi of x plus y plus z comma xy equal to 0. Now as usual, first I consider method 1. The method 1 is nothing but when the pi of u v 0, then it's become dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y equal to 0. Now I'm going to take u equal to x plus y plus z, and then v equal to x y z. Here xy is an independent variable, z is the function, it's a depending on x, y. Therefore, I'm going to differentiate with respect to x, dou u by dou x. For here x variable, when I'm differentiating x with respect to x1, y is a constant, we consider 0, but z is a function, therefore dou z by dou x, dou z by dou x. And for this term, dou u by dou y, again I'm going to differentiate x constant, I'm going to consider y1 and dou z by dou y, dou z by dou y. Now for dou v by dou x equal to, here when I consider x is a variable, z is the function, y is the constant. Therefore, I'll take y constant out, and x z is a depending variable, z is on xy. Therefore, uv form. What is a uv? D by dx of uv equal to uv dash plus v u dash. I'm going to apply with this formula. Therefore, x I'm taking when differentiate z, dou z by dou x plus z is the v and the x differentiation 1. And dou v by dou y, here x is the constant. Now I'm going to differentiate with respect to y. Y variable, z is the function, therefore y into dou z by dou y plus z into y differentiation is 1. And now use some notation, dou z by dou x is nothing but p value. Now I'm going to substitute this value for the determinant form of Jacobian. Now 1 plus p, 1 plus q, and then x, I just multiply with this term is nothing but y into xp plus z. Then this term is x into yq plus z. Now when I multiply this, y x yp plus yz, then x yq plus xz, and then I'll take this equation equal to 0. equal to 0. Now the cross multiplication, this is the determinant of this value, 1 plus p, then xyq plus xz minus 1 plus q xyp plus yz equal to 0. When I multiply these values, multiply with this term xyq plus xz, when I multiply p, xypq plus xzp, then multiply with this term and xyp minus yz, then minus xypq, then minus yzq equal to 0. And any term possible to cancel, then we can do it. For here xypq possible to cancel, and any other possible xyq and then xzp, so not possible for cancellation here. Therefore this is our final solution, xyq plus xz plus xzp minus xyp minus yz minus yzq equal to 0. So this is our result. Here the function is eliminated. Thank you.